Hello, everybody. Today we're going to be talking about dehydration synthesis and hydrolysis. So, dehydration synthesis and hydrolysis sound like very big, nasty words, but they're very simple terms. They're used to describe how monomers and polymers, monomers and polymers, how they join up together, how they form a link between them. So these are the two processes. One of them, the dehydration synthesis, it makes the bonds. So it is the one that is actually bonding together the two elements, and then the two monomers, and then hydrolysis is what breaks them up. So if dehydration synthesis makes and hydrolysis breaks, how exactly does that happen? See, let's start with dehydration synthesis, and I'll do it in, how about we'll do it in green? Yes. Alright, so dehydration synthesis makes the bonds. Now, what this means is that you are removing water. That's what the term means. Remove water. So when you do dehydration synthesis, what you're really doing is removing the water that's in there. So what does that mean? Well, if I have two monomers, let's say I have a carbon, there's a, let's call it a carbohydrate. Let's say here's a carbohydrate. Here is another carbohydrate. Let's try that again. Here is another carbohydrate. Right here. I have two carbohydrates. Now, on one end of a carbohydrate, I have OH. Actually, on both ends, I have an OH ion, which is a hydroxide or hydroxyl group. These are called hydroxyl groups. So hydroxyl groups, what happens is in dehydration synthesis is that you have these hydroxyl groups come together. This hydrogen and this OH, the hydrogen from this OH and and the entire group from this one are going to basically come together as water, because water is H2O. And if you look here, you'll see that we do in fact have two H's. We do have two H's and an oxygen in between. So that will come out as H2O, and that will actually end up leaving the system and entering the cytoplasm. And then you have one oxygen left over, and so what happens is that the final polymer, so the complex sugar, looks like this. It looks like two carbohydrate monomers, the two simple sugars, joined together by an oxygen. Another example we can look at is protein. So if we have on one end of the protein, so proteins have an amino group, NH2, on one end, and then we have an R group. I'll just call it R group. And then on the other end, we have essentially a carbon CO2H, or COOH. And so if I get two of those, NH2 and H2, and then I have R and then COOH. oops, COOH. So if I have it like that, so now what happens in this case is the same process, except for now it's with protein, it's amino acids instead of carbohydrates. But it's the same rule applies. Now with this NH2, I'm going to erase, and I'm going to actually change it into, I'm going to actually write it out fully instead of a chemical formula. I'm going to write it out. Whoops. I'm going to write it out as dihydrogen, like basically 2 hydrogens. Let's rewrite that as 2 hydrogens, and a nitrogen. This will make it easier to basically view things. Now, again, I have that OH, and I have the H on the other end, and so that will leave the system as water, and I, again, now have these leftover parts, which are going to come back together. NH2, R group, C, O, and then O will actually, in this case, act as the bonder, like the middle piece, and then COOH. And this will keep going on and on and on, so long as, however long the amino acid is. Now, hydrolysis, on the other hand, hydrolysis actually does the opposite. When we talk about hydrolysis, we are actually adding water back. So if I have these two carbohydrates here floating around, joined by their oxygen, what happens if I add water back? What would happen if I were to put water back in? What would happen? Well, the water again is made up of two hydroxyl groups. Made up of a hydroxyl group and a hydrogen group. So if I have this, then the respective hydrogen would go and join up with this oxygen and would break that molecule free. That monomer would then have its OH, and then this would get the OH part of it. The other one would get the OH part, and it too would leave. This would get the OH, and they would basically break apart. So hydrolysis is the combination of hydro. If we look back at what the term is, we see that hydrolysis is really hydrolysis, and lysis means to split. So we're going to split with water. And synthesis means to create. When you synthesize something, you create it. Dehydration means to remove water. So dehydration synthesis means to remove water, to create by removing water. So this is how monomers and polymers are joined together. It's the most common way.